welcome to our next session on distributed object graphs with MicroStream cluster. So this session is all about distributed apps and microservices with MicroStream. My name is Markus Kett. I'm CEO and co-founder of MicroStream. With my colleague Christian and our team, we are working on Java tooling for developers and database development for more than 15 years now. So we worked many years on the Eclipse distribution, which is a visual development environment. And here in this space, we in particular worked many years on the JBoss Hibernate tools to improve database development, to try to accelerate and simplify the entire development process. So this is our passion. So Java is our passion, and building tools is our passion. And of course, all these solutions are open source. So we love to work on open source, and we're also very active in the Java community. Let's have a look on the agenda for this talk. So we start with talking about what actually is MicroStream, what's the difference between traditional data storage, traditional Java persistent and MicroStream. Then we talk about challenges with MicroStream also. And then we will have a look on how traditional persistence and cluster architecture work. Then we jump into MicroStream cluster architecture. And in the second part of this talk, Christian, this time, Christian will jump into live coding and will show us a live demo. And I'm sure we will have time for Q&A. So we try all the time for many years to improve speed and try to simplify database development, because all the modern apps, they have to deal with tons of data and have to process data in real time. So performance is critical, and also not only performance, also saving costs in the cloud. And we believe MicroStream is a great approach for that. So this is the reason why we spend so many time on this project. What actually is MicroStream? It's a Java native persistence, micro persistence layer. You can compare it with Hibernate in terms of storing data, in terms of storing objects. But it's from the technical perspective completely different. So you can store your objects, but with MicroStream, we store native Java object graphs, which means there is no more object relational mapping. There's no more data conversion behind the scenes. So we store real Java object graphs, and we are able, vice versa, to load Java object graphs and restore it in memory when it's needed. And with MicroStream, you're able to load any subgraph, so you don't have to load the entire object graph, the entire state into the memory. You can really load individual subgraphs, object references when they're needed. So the loaded object references are merged directly into your object graph, so you don't have to deal with object copies. And so you are able to use your object graph like a in-memory database, which is super fast. It's pure Java, and you can process data in microseconds, because searching Java object graphs with, for instance, Streams API, GraphQL, will take only microseconds, and this is really incredibly fast. The complete project is open source. You can download it via Maven, and the code, of course, is on GitHub. It's under EPL, so you can really use it for commercial purpose also. It's integrated with Project Helidon since last year. So thanks to Dmitry Kornilov from the Helidon team, who integrated Helidon with MicroStream. So we worked many months together to make this possible. Now MicroStream is also integrated with Micronaut, so great news. Thanks to the Micronaut team. We also joined the Micronaut Foundation as a sponsor. So this is really great to work together with these guys on open source projects. All right, to understand what MicroStream actually is and what's different between MicroStream and traditional data storage or object storage, let's have a look on the architecture. Here we have a Java application, or the architecture of a Java application, or a microservice. The business logic is written in Java. We have an object graph in memory. In Hibernate, this would be your Hibernate entities. With MicroStream, there you can use plain objects, plain old Java objects, POJO classes, no specific requirements to your classes. So you have an object graph. There are no rules and no requirements to your object model. Do whatever you like. But with Hibernate today, this is a little bit different. So if you want to store your object in a relational database, this is actually not possible because of the differences between data structures. So object graphs are incompatible with the relational model. We have various impedance mismatches here. So both technologies actually don't fit together. This is challenging, and this is the reason why we need object relational mapping framework. Hibernate is a standard, de facto standard here, and it's a great framework, and we have really spent 10 years on using and improving Hibernate in our own tools. Then we have the NoSQL database approaches, and the new NoSQL databases introduce completely new data structure or formats. But when we compare all these formats, then we see that they all also incompatible with Java object graphs. So we need a mapping or data conversion here as well. So it's the same with a NoSQL database. So in any case, we need object relational mapping or data conversion through every single read and write. And so this leads to more complex architecture. This leads to, and through runtime, to latencies and loss of performance. You need more CPU power. This increases the cost of infrastructure. So there are many challenges. To improve the performance, we are used to use a local cache. So this is very common to run a JPA Hibernate application with the local cache. So then you can accelerate your queries. Significant. It's much faster, but we can see the architecture gets more complex because now we have another layer. We have cache configuration and so on. So this is in practice challenging and complex. With MicroStream, we follow a completely different approach. So with MicroStream, as I mentioned, we keep objects in memory, plain Java objects without any, there are no rules or requirements to the objects. You can design it like, completely individual. So you can use all Java types, everything that's supported. You can use inheritance, you can use circular references, and create complex relations between your objects. Doesn't matter, whatever you build, MicroStream will be able to store it. So, and MicroStream is super tiny because it's a small Java library, and there are no dependencies. There are only dependency to the JDK. That's it. No additional libraries used. So super lightweight API. With MicroStream, we read the data, the objects directly from memory and serialize the objects in a binary format to the file storage. So this is the functional principle. We don't use Java serialization for that. We use the MicroStream serialization, and it's because we are able to not create a snapshot from the entire system state. With MicroStream, we only store deltas. Only the changed objects are stored persistently on disk. And vice versa, you're able to use lazy loading to load single subgraphs and merge it directly into the object graph. So this is this leads to a very convenient programming model. It's completely object oriented. There is no query language needed, and you just have to call store methods or get methods. That's it. So if the object is not in memory, the MicroStream will load it. And so this is really convenient. Just call getter, no more classic selects. We store binary data, and which means we can store it in plain files. You can use blob stores like AWS S3, but we also have connectors to traditional database systems. So it's also possible to store your binaries in a relational database. But keep in mind, there is no more relational model created by MicroStream. It's not object relational mapping framework. We store binaries. But we also have data connectors to NoSQL databases and in-memory databases and distributed caches like Hazelcast. You can store also your objects in Kafka seamlessly without any JSON conversion. So you can really use MicroStream for various purposes. The architecture is super simple. We only need a JVM or a native image for a microservice. That's it, nothing else. So as I mentioned, there is no more mapping, no more conversion, which means we eliminate these latencies. This accelerates I/O operations tremendously. Yes, it's almost the same speed as your hardware. So it depends. Speed depends only on your hardware. It's super fast. And then with Java streams, we are able to search the object graph in memory. And now we use the object graph in memory like an in-memory database. But also keep in mind, MicroStream is not a database system. So we keep the data in memory, and we can use Java core features like streams to search on the object graph. And here you also have to care for concurrency, but you can solve all of this with core Java features. So this is not a big deal. Processing data in memory is super fast with streams. We talk about microsecond response time. So all of your queries on the object graph, mostly. So it depends, of course, on your database size or the complexity of your object graph, but also if you have really complex object graphs, circular references, it will take microseconds. And this is up to 1,000 times faster than common JPA queries. This is the difference. Here we have can have a look on all the supported data storages, and they are also now open source. So you can also now use MicroStream to store data directly in AWS S3. It runs wherever Java runs. The only requirement is Java version 8, and you can use it also with JVM languages, and it runs also in Android. MicroStream is not only a serialization, so serialization is only the core of MicroStream. We have an implementation, of course, for the JVM and implementation for Android. It's completely the same API, same library, optimized for running on Android devices. We care for class changes. So we have a so-called legacy type mapping. So it managed class changes automatically through runtime, and many things else. So like a file system garbage collector, it's because we store the binaries appended on disk. So it's different to relational databases. We never overwrite a record like a relational database do. We always store the objects appended to your file storage, appended lock strategy. And to avoid that the storage grows more and more, we have this kind of like garbage collector that works on file base and removes the legacy objects from your file storage. You can configure that. You can also keep your legacy objects in your file storage if you like. So it depends on you. We have file system abstraction, which means you can run MicroStream in a container while the storage is outside of your container. Storage can be in a blob store, as I mentioned, in a database, wherever you like. We have database connectors, of course. We have a REST interface that allows you access to the storage data, to the binary storage data. It's for development purpose. And we have this MicroStream storage browser. It's a graphical user interface. It allows you to browse through your storage data. And of course, we have native backup functions. It's because if you use plain file storage, then MicroStream provides you also backup functionality natively. We have converter to CSV, and further converters are in progress for instance, protocol buffer, JSON, and so on. And now we have a MicroStream cluster, and all these together is MicroStream. There are some rules with MicroStream. This is very important. So it's because we talk about in-memory computing, we talk about in-memory data processing. So the question is, how many memory do I need for MicroStream? So and the answer is, yeah, you can use, sorry, this is the correct slide. So if you have enough memory, of course you can use it, load all the data into the memory, then it will be super fast. Then it's pure Java, it's pure in memory, no latencies. But if you create microservices that should have a fast startup time, perhaps this is not the way to go. So it depends on the use case. If this is a monolithic application, you start it and run it for 2 years without any downtimes, then you can load everything into memory. But if you don't have enough memory, then you're not in trouble with MicroStream, and it's because we provide lazy loading. So MicroStream initially loads only the object IDs of your object graph into the memory. As soon as you call a get method, then MicroStream loads the object reference into the memory, and then you can query it in memory. Mostly developers ask, what is if I have really huge collections, for instance? This is not a problem because now we introduce pageable collections. Then you can load even biggest collections step by step automatically into the memory. And the garbage collector cares for memory management, and you also have control of your lazy references, so you can clear lazy references anytime that are not needed anymore. You can create a timeout, so you have full control of your objects in memory. There are also some architecture rules. So MicroStream as it is a single node storage. So MicroStream runs within the same JVM process of your application or your microservice. It's built to persist the data of a single JVM into into one data storage. Is it possible to use multiple data storage for sharding, for instance, or to create backups? So yes, this is possible. This is no problem. You can execute multiple stores that store your binaries into multiple data storages. This is not a problem. The only challenge so far was building distributed applications with MicroStream. So if you have multiple instances of your app or microservice, then it was not possible that all of these instances share one and the same storage. So this was actually not allowed because of concurrency issues on writes. And now we have the solution for that, and this is MicroStream cluster. So we do it by object graph replication. But before we have a look on the MicroStream cluster, let's have a look on how traditional cluster architecture work. So here we have traditional the architecture of a traditional Java application with traditional Java persistence. When we want to distribute our application or our services, then we start multiple multiple instances of our app or service. They are containerized, so this is really convenient in the cloud. Then mostly we have problems with our cache. So it's because the local cache has to be updated as soon as data change in the database. Then it depends on your cache policy, right? So it depends on your cache configuration. But so this is the challenge with caching in general. And to solve this problem with distributed apps, using distributed caches is the way to go. For instance, Redis. So we add a distributed cache, then we can be for sure that we don't have inconsistent data. This is, of course, challenging. It's depends on cache configuration, but this is the common architecture. And this is very important. Here we can see that it's important because of the difference between the traditional cluster architecture and MicroStream architecture. Here we can see the application is distributed, and your cache is also distributed. And mostly, we also need a replication or clustering of our database. Then we have another cluster. So we have 3 cluster solutions in our architecture: distributed application, distributed cache, and distributed database. So this is very important because MicroStream architecture is completely different. And in practice, sometimes we add Elasticsearch cluster or perhaps other solutions like event streaming, like Kafka. So architecture gets more and more complex. With MicroStream now, we are also able to build distributed apps and microservices, and we do it with object graph replication. So now we are able to replicate the object graph in memory through 100 or even more JVMs seamlessly. Here is our standard MicroStream architecture. What we have added now is Micronaut. It's because MicroStream is integrated with Micronaut. So we also can use Helidon. So we will also introduce a MicroStream cluster using Helidon. And then we are able now to cluster the application because the data belong to the app. The persistence layer, MicroStream belongs to the application or to a microservice, and now we distribute the application, and now we have a MicroStream cluster, and we don't need a local cache anymore, which means we don't need a distributed cache anymore. It's because we distribute the object graph in memory. This is the big difference between classic cluster infrastructure and MicroStream cluster architecture. And we also don't need to distribute a database. So it's because we don't use a database system anymore. Each MicroStream node has its own storage. So this fits great with the microservice rules, which mean each microservice that stores data should have its own database. With MicroStream, this is now possible. So tiny architecture, super simple, and each node is extremely fast, microsecond response time, and so these are great benefits. All right, so let's see how the code looks like. Christian, are you ready?
Yes, I am. Thank you, Markus. So yeah, let me share my screen first. Okay, here we go.
Please ask questions, by the way, ask questions in the chat, and also give us your comments. So it's very important for us to improve MicroStream.
Okay, so let's talk a little bit about the user or developer workflow and how you should use the cluster in the future. But before I jump into the code, let me just summarize the properties of our cluster. So basically, the cluster should be or will be high available. So that means that the cluster will guarantee an accessible response time, no matter how many requests we have. I think that's one important thing. And this is based on object graph replication, as Markus said before. That means that our read accesses are scalable horizontally, and I think that's a very important thing. The cluster is based on eventual consistency. That means you will not get always the newest data, but the less read nodes you have, the more newest data you will get. And but when you have for example 10 read nodes, for example, it needs a little bit to replicate all data through all that 10 nodes, and yeah, that might be possible. Then you will get older data in the end. Another point is that also Markus mentioned is clustering the data, and not only the data, we also clustering the business intelligence. And the reason for that is when we start to create that cluster, we were really aware of the architecture itself, but the question was, okay, how can we get the data, the domain objects from the users, and how to get the controller classes and REST endpoints and so on. And the idea was, okay, let's provide or let's deploy a normal Micronaut or Helidon project on the nodes itself, and then provide a front end where the users can enter all these informations, all the entities, domain objects, fields, and so on. But in the end, we would have the same mess like on relational databases. That means that we have on the cluster side the definition of objects and so on, and also on the client side we have to take care about all that object stuff and so on. And that is not the way we want to have that. And another idea was, okay, let's provide a standardized Micronaut or Helidon template or project template with some MicroStream cluster stuff inside, and let the users enter the data directly insert in that project. So that means the users or the developers can enter all the entities, the REST endpoints, and so on directly to a Micronaut template or Helidon template. And in the end, this template will be handed over to the cluster, and we do all that validation stuff on the cluster side, and then the application will be clustered. And this is why it becomes more and more not only a data cluster, and it becomes more, yeah, let's say a business intelligence cluster or application cluster. And it should be easy to use, for sure it should. So, okay, that's the part of the summarization. Let's get into the code. So step one, what we need to do is, as I said, let's create a normal Micronaut or Helidon project. In my case, I created a Micronaut once because I'm more familiar with Micronaut. So that means let's create that project. Let's add the MicroStream cluster API to that. Let's do some instantiation stuff of MicroStream and create the storage as usual, nothing special in it. Then we have to set, or we have to provide the REST endpoints we need to the controller classes we need. And this is the same way, yeah, like to do this in a normal Micronaut or Helidon project. Then providing that project to the cluster by using the Git repository, for example, and the jar file. In the future, there might be more possibilities to hand over the application, but yeah, let's see what happened then. Yeah, let's jump into it. Let's have a short look to the project itself. Where is it? Here we have. Okay, so what you can see here is a normal Micronaut project. I called it cluster demo. You will also be able to find that on my GitHub account in the end. But let's get through it. So first, we need one dependency. As I said, this is the, let me check. Yeah, here we need, so the MicroStream cluster API in it. That is one important part. And then we need our two classes, as always. We have one DB class for some instantiation stuff of the storage and so on. We need our application or our storage root. As always, we have the storage, and we have some methods to provide these entities or these objects to external or to other classes. Then we have a data root. As I said, that is always really straightforward. Then we have one domain object, which is called, in my case, it's a product object just for demonstration purposes. And we have a controller class. And as you can see here, this is a really straightforward Micronaut controller class, nothing special in it, some get, patch, and put methods, and also a delete one. And this can be deployed to the cluster in the end. There are two special classes we need in that project. The one we have here, this is one class which extends the storage cluster controller. We need that class that some informations will be or should be provided to the cluster itself, that the cluster can do all that replication stuff in the background. So that is one part we need. And the other class is also the storage manager provider, and it provides the storage itself to the cluster. So this is also really important to do the replication stuff. So as I said, we need these two classes. These are the special ones, I would say. All the other stuff is yeah, it's quite common, I would say. Okay, that's the project itself. Let's jump back to the presentation. So when we have a look to step 2, let's talk about the configuration and the ordering of MicroStream cluster. First of all, yeah, of course, you will need a MicroStream account to get access to the Cloud Console. And to order the cluster at the moment, there are some of the most important properties, or some of the necessary properties we need. You can choose a namespace. You can choose a property which defines the way how the cluster works internally. That means we have an auto-scaling cluster for providing, or let's say we have a minimum and a maximum amount of nodes or replicas we need to have. So that means the auto scaling takes care about yeah, let's say about the traffic, and the more traffic we have, the more nodes will be started in the background until a maximum amount of nodes. But it's also possible to have only a static amount of nodes, let's say 3, for example. Then yeah, we are totally fine with 3, for example. Then you have to choose the amount of CPU and RAM that we need for the nodes. Let's get into that later on, and then you have to choose the way to deploy. And I'm pretty sure this is just a small amount of properties just for testing purposes and so on, but in the future there will be much more properties, especially for the cluster, to do all that configuration stuff, security stuff, and so on. That's part for the future. Let's go back to the user interface. Here we are. That is the cluster front end, and this is yeah, I would say a rough prototype, just to do some testing stuff internally. But we have one cluster running here. You can see that here. This is already running, and we have 2 replica nodes. We have 2 read nodes in that cluster. And yeah, as I said, I did that before because, you know, you have that Murphy's law within presentation. If someone isn't working as expected, so I can use this cluster. So, but yeah, let's do that. Let's create another cluster. So let me click on add cluster, and as you can see here, you are able to choose between 2 clusters, but the left one is the important one, the high availability one. Let's select this and say next. And as I said, now you are able to provide a namespace for that. Let's say we say copy of products, for example. That is why a product namespace is already in place. So let's do this. I said, okay, Micronaut is the way to provide the data, and I decide I want to use a static amount of replicas, and each replica should have 1,000 millicores and 2 gigabytes of RAM, and we have 10 gigabytes of disk space on that. I'm totally fine with that for the demo. Let's say next, and now we need to have the repository URL. So give me just a second to copy that from my GitHub. Here it is. So let's add the URL, and then we can choose the branch we need. And the cluster, or the API of the cluster, will automatically pull the project from the repository. And now we can say click on ready. And now the cluster is setting up, so it's preparing for the moment. Now we have a little bit time to answer some questions, because that needs a little bit, around 3 minutes around, to set up all that cluster stuff in the background, to configure all the backup nodes, the replica things, and so on. So if there are any questions, so feel free to write down to the code or to the chat. And yeah, let's ask some questions, or yes, let's answer some questions. But during that setup, we also can use the already existing ones. That doesn't matter. In the end, you will get the information how to connect to that cluster. In the first example, we have the URL here, and as I said, there are 2 nodes up and running. And we have also access to a Grafana board. And we have one question: which cloud will be used behind? At the moment, it's an AWS EKS cluster we used for that. But there are more. We plan to use different cloud providers, but we started on AWS EKS. Let's have a look to the Grafana board, for example. I think that's also quite interesting. I tried to put this down. Yeah, okay. Here is the board. Let's have a look. Let's browse into it, and let's check the namespaces. And there should be one cluster. This is the cluster which is already up and running. So, and as you can see here, here are the nodes. We have some proxies in it. We have backup nodes in it. There is a Kafka instance available for message brokering inside the cluster. And yeah, I think that's very important, especially for development. And you will also get access to a board when you're ordering that cluster, that you can have a look to what's going on in your cluster and to see how it scales and so on. I think these are very important informations to have. Okay, yeah, as we can see here, we have already one node is available. Let's use the Postman for a small test of the cluster. I already prepared some example endpoints or some requests. Let's check if the cluster is working. So as you can see here, this is just a list of all objects we have. There is only one object inside the cluster, but we can add a cluster. Let's say, let's add a second car. Yeah, these are just a smaller example to explain that. Second car, let's say this is this is a description. For example, let's change the price, and then we will be able to send that to the cluster. And let's get the list again. Yeah, and now we get two cars. Let's see if we can. Yeah, that looks a little bit better. Then we have the cars, and that is how the cluster works. It's really straightforward, pretty easy to handle that. The most important things will done in the background by the cluster itself, also the validation of your project itself. Let's check if yeah, now you can see the second cluster is up and running, and let's check if it's also available in the Grafana board. Namespaces should be there. Yeah, here it is, copy of products. And also this cluster is now up and running. Yeah, it's kind of like magic, I would say, but this is the way to do with the cluster. There will be, as I said, there will be much more properties to adjust the cluster itself in the future, but I think that is the first preview of a cluster. It will be also available soon as a let's say beta or alpha testing stage. So yeah, let's keep on track. And I would say it's time for some questions. Give me just a second to jump back to the presentation. Yeah, as we see, getting access to the cluster, you will get that by the console, and then you can connect with your consumer application. And now it's time for your questions. Or Markus, is there anything to add from your side? How many regions will be available in the next 6 months? I think that is a property which will be available pretty soon, because it's really easy to set up. We are able to decide which regions can be deployed, and yeah, it's totally up to you basically, but we will provide most of the regions, I think. Some more questions from your side. No questions so far. Maybe someone, you can also unmute and talk. That is also okay.
So I think the big deal here is that the entire application will be clustered. So this is you don't have to think about how you scale your app or your microservice. So this is automatically done by the cluster. And also then scale out, scale in automatically. This will be you'll be able to configure that in the cluster user interface, so that if the load goes up, then you can scale out your app or service and run and start multiple machines. And if the load goes down, then the cluster will automatically shut down the nodes. So you can really save money in the cloud. And with the performance of MicroStream of each node, you will also able to store tons of costs, tons of cloud costs, because you don't need distributed cache anymore. You don't need a database cluster, so you can really save tons of cloud costs with MicroStream. And it's simple to configure. It's simple to implement it, because just plain Java objects, no specific requirements for your persistence, no specific requirements for the cluster API. This would be my question to you, Christian. How does the cluster API looks like? Are there new specific requirements or anything to is anything important to know about the cluster API?
Basically not, and thanks God, not, because it stays quite the same. But there are some rules. Of course, there are some rules, because we especially for here, as I said, you can enter your own business logic, whatever you want, but you have to let's say, to take care about some things or some stuff of the cluster. And that's why we will provide newer methods like the storage, for example, or the store method. There will be maybe there will be a store or a cluster store method in it that operates more properly with the cluster itself. And also, what also is very important is to have a proper validation of your project, so that whenever you hand over the project, then we have to do some proper validation that ensures that the application works properly on the cluster itself. We have one question: will be a direct connection to Replication? Of course, yeah. That is also, that goes hand in hand with the RESTful or the REST connections or REST endpoints, which is planned in Replication, and you will also have a proper integration to Replication. Yes.
There's another question.
There is another question. Maybe DevOps work will be hard. How to handle debug logs and crash issues and so on. This is what we are working on now. So I would say that the basic stuff is already in place. We have the architecture, we have all that stuff. Now we need to implement all that convenience, as you said, the logs, the debugging stuff. It's, yeah, I would say it's kind of like the same like the AWS console. You will get any information of the cluster you need to handle these cluster. And it's also possible to order. We will have an AWS integration of that cluster, so there will be a REST API to work with your cluster. You will get all the possibilities to handle that, so don't worry about that. You will get that.
Yeah, this is also the reason why so we provide this as infrastructure as code, so you can run it on on-premise hardware, and we also provide a MicroStream Cloud interface, so that you have you can start and maintain your cluster with only some mouse clicks, that you don't get in touch with all of this DevOps stuff. So this should be very convenient to use this MicroStream cluster. So
there is another question from the chat. Means that the business logic is twice in Replication and in the controller class? No, that's not the case. So it's totally up to you. And of course, it makes sense to keep the business logic where it belongs to. So that means when you have business logic, which is more related to the data, it would be great to keep it in your cluster. So that is kind of like, yeah, let's say, like, what is the name of the? It's more than a function on the database itself. So keep that business logic on the cluster, and all the other business logic you need on the UI side, because you need the reference to the UI, then you will have that on the client side. That is totally up to you. Okay. Another question, can you explain the high available implementation, how and when the read nodes promote to a write node? So basically we have, there is a load balancer in place, and these load balancer, and there is also a proxy implementation, proxy container, and it decides on the type of the request. For example, patch and put, that is the first plan. Patch, put, post, and delete, all these requests are will be forwarded to the write node. Only the get requests will be forwarded to the read nodes. This is the basic or the default way to work with that. We are planning to add some more functionality in it, but it depends a little bit on the performance we get, to enter some special body information to ensure that this request goes to the right node, yeah, this is the way basically it works, I would say. And the other stuff is, okay, you have a node replication, you have one write and multiple read nodes, and that ensures the high availability, I would say. Is that okay for you? Is that... Okay. So maybe that's interesting. So let's jump into the presentation. You can see it, that this is the load balancer, and this load balancer will take care about the routing of the traffic. I'm not sure if I get this right. Is the MicroStream Cloud followed by deploying websites as a whole? It might be possible to do that, but I'm not sure if that is the most important approach for the MicroStream Cloud. But yeah, let's see what happens in the future. There's another question from Philip, what to keep in mind of security, HTTPS, and so on. Mostly all of that should be done by the console in the end. So you will have the possibilities to take care about that. It's mostly the same like to handle this in the AWS console. You will have that also on our side, and hopefully it will be much easier for you, because maybe we can do some convenient stuff in it to keep that points away from you. So let us keep track of the security stuff. Okay,
right.
I think we are right in time. Thank you for attending the presentation.
Thank you for joining.
I hope you enjoy the conference, and enjoy. Bye.
Thank you. Bye-bye.